Hello everyone, welcome back to the DSA for Beginner series. So far, we have learned arrays and the two-pointer techniques. Today, we are going to learn two of the most important data structures in computer science, which is stack and queues. So these are used everywhere from browsers, operating systems to messaging systems like Kafka, task, schedules, task scheduling systems, etc. By the end of this video, we'll understand what is a queue, what is a stack, and some real world examples. We'll see a couple of examples for stacks and queues. So let's begin. What is a stack? So stack is something which follows the principle last in, first out. Last in, first, first out. Basically, the last element which is inserted in the stack is removed first. So think of a stack of plates. When you add a plate, that means basically you're going to stack each plate one on one. Yeah. So stack is how. Let's think of a stack of plates. So when we add plate one on one, when you add a plate, so basically we are placing a plate on top of the stack. So that's how the first plate will be removed. So which is on from the top of the stack. You cannot remove a plate which is from the bottom of the stack or anywhere from the middle of the stack. So this is not possible. So basically we'll have to remove it from the top of the stack. So let's have a visualization of the stacks. So basically first we are inserting 30, 20, 10. So top of the stack will become this. So here we can see the last element which got in was 10. So that will be removed first. So if we do a remove of stack dot pop, which is basically removal of the element, that means 10 will be removed. So again, the top will be reassigned to second element. So now the top will become 20 will be the top of the stack. So what all operations stack has? So basically stack has stack dot push. This is to push the element onto the stack. Push the element onto the stack. Stack dot pop. This is to remove the element. Remove the element from the stack. So there is one more operation which we can see from in stack, which is peek. So this is basically we are just seeing the top of the stack and not removing it. So stack.pop will directly remove the top of the element, but stack.peek, this is to view the top of the top element of the stack. And we have stack.is empty. This is to check if the stack is empty or not. So let's take an example of let's have a couple of operations on stack and see how it performs in Java. So let's take stack of integer new stack of so let's push 10 stack dot push 20 stack dot push 30. Then system dot on dot println stack dot peak. So this will show top of the element. Dot pop. Again same sys out of stack dot peak. So basically what we're doing, we're just pushing 10, 20, 30. And again, if we do a stack dot peak, this will print 30. After this will remove 30. Now top is pointing to 20. Again, stack dot peak will print 20. So what are the real world examples of stack? Where are these used? So basically, if you see Google, YouTube, or any browser, if you press a back button, so it takes you to the previous visited page. So how that works? That is from stack behavior. So basically, what all website that we have already visited, that is put on stack. So whenever you press back, the top of the entry will be deleted and it goes to previous website. Yes. So let's see what all other stack implementation in real world. So basically we have real world examples. One which we saw was browser history. Can do expression evaluation. We'll explain this part in upcoming tutorials. DFS traversal. Backtracking. So all this, right, we'll see in our upcoming tutorials. Let's jump on to our next topic, queues. So what are queues? So as the name suggests, queue is like whoever comes in, as you have seen in any ticket counters. So the person who comes in first will have the opportunity to buy a ticket first. Same, the principle is first in, first out. Basically, first in, first out. So how can we visualize the queue? So let's say this is a queue. So queues, whenever the first element comes in, 10, 20, 30. So this element goes out first. Basically, this is visited. This is this gets the opportunity to, if we remember the example which I gave, ticket counter. So the person 10 will have the opportunity to buy ticket first. Same goes with second and then third. So what all operations we have in queue? So what we saw in stack, same way to add it into the queue, we have queue dot offer. To add it into the queue, add into the queue. Queue dot all. This is to remove from the queue. We have queue dot peak as well. So this is to see what element is on the front of the queue. And then we have one last, which is queue dot is. This is to check if the queue is empty or not. Okay, let's see a similar example what we saw in stack. Okay, so let's see this example. So what we are doing? So we are adding queue 10 into 10 into the queue, again 20, then 30. So queue dot peak will print the front of the queue element, which is 10. Then we are doing a queue dot poll, which is remove the front of the queue. So the first element is removed. So 10 is removed. Now again, the peak, queue dot peak, if we do, the front of the queue will become 20. So what all real world examples which we can think of when we remember, when we think of queue? One thing which I already mentioned, ticket counter. Second one, okay. So what all real world examples which we can see in queue, which uses queue basically? So one is ticket counter. Second one is a printer. So where printer uses a queue to schedule the jobs of a printer job. Printer. Then CPU scheduling. Then we have Kafka. What is Kafka? We will see in our future tutorials. Then we have BSS traversals. We have task scheduling. So these are some of the examples of queue. Okay, let's summarize like what all we studied today. So what do we have? Stack, queue. So order of execution. So stack we have first in, first out. So in Q we have last in, first out. So insert is on top. So here rear end of basically end or end. Remove is from top of the stack. Here it is from front of the queue. Example, if we take plates or books, here ticket counter. Yeah. Okay. So today we learn two fundamental data structures. Queue, which follows last in, first out. Sorry, stack, which follows last in, first out. Queue, which follows first in, first out. Understanding this concept is crucial because they appear in coding interviews, system design discussion, and real world examples. In our next video, we'll learn about linked list and how they differ from arrays and why companies love asking linked list question interviews. See you in day 5. Happy coding.